Honors lesson is about domain and range in discrete and continuous functions. So our domain is the set of all possible x values in our relation. The range then is going to be the set of all the possible y values in a relation. So a discrete graph is a graph of distinct and separate points. So this one is going to have dots. Where continuous, it keeps going and going and going. This one's going to have lines and curves. So dots versus connected. So this would be a discrete, and it's written in set notation, meaning that it's written with ordered pairs. And this one's written in inequality notation, or we can use brackets and parentheses notation, which I'll show you how to do that. All right, so first they've given us a different discrete graphs. So if we were looking at ordered pairs and we wanted the domain, we would look for our domain. We're going to list the set of x values in our ordered pairs. So I would have -2, and you always list them from least to greatest. So we use this little bracket key here, and we say my x values is, again, the list of all of my x values. I have -2, 0, 2, and 3. If at any point, like say we had two -2s in here, you don't have to list them both. You're just saying -2 is one of the x values. Now, what about our range is going to be our y values. So our list of y values. So here we would have 8, 2, -4, and -7. Oh, whoops, not a parenthesis, sorry. A bracket. And again, I think Delta Math has you list them least to greatest, so I'm just going to start that way. So you have -7, -4, 0, and 8. All right. Now let's look at our table. Oh, excuse me. Again, these would represent x values. These would represent y values. So my x values would be 1, 2, 3, and 4 in that table. My y values in that table would be 3.5, 7, 10.5, and 14. From your graph, this is where, again, we have to know the difference between our x and our y axis. So I need my x value. So this one's at -1. This point right here is at 0. Then I have a point at 1, a point at 2, and a point at 3. If I'm looking for my y values, I'm looking this direction. So it's both of these are 3, so I don't need to put it twice. And then both of these are 1. So I'm, again, going to list least to greatest. I would have 1, 2, and 3. So those are our y values. Our x values went this way. All right. The last one, they've given us an equation. They've actually given us our domain. They said they want us to use the numbers 0, 1, 2, 3, and 4. And they're saying, what happens when we plug those in, 0, 1, 2, 3, and 4? So we're going to replace x with 0. So 30 times 0 is 0, and 0 plus 50 is 50. That means that y equals 50. So I have 50 as my first one. My second one, I'm going to replace x with 1. So I do 30 times 1, which is 30, 30 plus 50, which is 80. The next one, number 2, is domain of 2. So I do 30 times 2, which is 60. 60 plus 50 is 110. If I had 3, it would be 3 times 30, which is 90. 90 plus 50 is 140. And our last one, 4 times 30 is 120. 120 plus 50 is 170. So on those ones, you have to plug them in. All right, so what we're going to be doing though is figuring out how to write them when they're not discrete. In other words, where it doesn't just have points, like it's that continuous, you can't see like, oh, it just keeps going. So again, we're still going to be looking for domain at our x-axis. We're still looking at our y-axis for range. So you can use with how to use this is you're going to use open circles, so things that look like this. You're going to use greater than or less than, but I actually am going to teach you how to write them with parentheses. I think those are easier. So parentheses are open, and greater than equal to has to have that equal to sign on it, or we can use brackets. That means that it's included, is used with closed circles. So closed circles, or a curve. If it curves, then it also can be used with closed brackets, or with brackets, which means that it includes those. So when you look at this, I have a closed circle, and this is never ending, keeps going forever. So when we look at this, we can write, I'm going to show you both ways. We could say that x goes on, x needs to be greater than or equal to -5, because that's my x value right here. This x value, however, just keeps going. So you can write it like that. Easier than that, well, I think it's easy, would say that it includes the -5. That's what this bracket represents. It includes that -5, and it goes clear to infinity. And I did an open bracket like this because it never ends, so it can't include infinity because that just keeps going and going. Now, our range I'm going to do in pink. Our range is the highest point and the lowest point. So this one would be y is less than or equal to 3. And again, bracket notation would be, it starts at, well, it's at 3 here and infinity here, but it will be negative because it's going into the negatives. So this goes, let me fix this, always again from least to greatest. Negative infinity, and it stops, it doesn't go bigger than 3. So a closed bracket means that it either is a closed circle, I keep saying a closed bracket. A bracket means that it's either a closed circle or it curved at some point. So the reason I show you both ways is because I feel like it's easier to write it with bracket notation rather than inequality notation. I'm going to show you this one, and then I'll show you why I think it's easier. So for domain, I have, let me stick with the right color. So this is this one and this point. So my domain is at 0 and 3. And it stops there because there weren't arrows on that, okay? So this says that I start at 0, and 0 needs to be less than x, so this would be red. You always read your variable first. This says x needs to be greater than or equal to 0, but x needs to be less than or equal to 3. So you can write it that way. It's not wrong. However, easier than that would be bracket. Since these are closed right here, they weren't closed circles, but they ended. They didn't keep going with an arrow like they did here. We're going to use these. So we're saying that this goes from 0, comma, to 3 and anywhere in between. So 0.1, 0.0002, clear up to 3. On my range, the highest point is 60, the lowest point is 0. So again, y is greater than or equal to 0, but y is less than or equal to 60. The curved point means that it includes that point. So again, if we were to write this, it goes from 0, including 0, to 60, including 60. All right, on this one, again, here's my domain. So it goes from -5 to +5. So since it's an open circle, it's an open bracket or just a parenthesis, and it has a closed circle here, so it ends at 5. And this means that closed bracket, or whatever you want to call it, means that it includes 5 as well. Then if we have our range, this is the lowest point. I gotta make this bigger because I cannot see. And this is my highest point. And does not include this because that was a close or an open circle. So it doesn't include that. So we're gonna do again an open 3 and then a closed at 6. And that's what that would look like. All right, I'm going to do one more for you, and then I want you to try it. I want you to pay attention right here that those keep going and going and going. So it's going to keep spreading and getting wider and wider and wider. Hint, hint. All right, so again, on this one, let's start with our here. Whoops, I don't want that color. I want to start with my domain, which are my x values. So it goes from here. Now, this keeps going forever, so it's never going to end. Although it only shows me to 8, this keeps going. It's going to keep spreading bigger and bigger and bigger. So, since it started at 30, since it started at 0, I'm going to include 0. And it's going to end at a positive infinity with an open bracket because it's never ending. When I say it ends at infinity, that means it's never ending. It keeps going, going, going. Now we're going to look at our range, which are our y values. So this one starts at 30, and it also goes forever. It never ends. So this would also go to infinity with an open, or just with a parenthesis. That means that it never ends, because even though we only see it right here, that arrow indicates that it keeps going. So it's going to keep spreading bigger and bigger. All right, these are the ones that try to throw you off. I know they're not numbered, but this is 0 right here. That's my center. And our domain is from here to here. My range is from here to here. So write those, and then we'll check them. Again, our domain it keeps going forever and ever and ever and ever and ever and ever, ever and ever. Even though right now this is as far as we can see, it keeps going. It keeps going, so it's going to keep spreading. And then our range maxes out here, but again, it is never ending. It keeps going down. So take a minute, push pause, and see what you would get for your domain and range on that one.